Hello, everybody. My name is Vanessa Evers. I'm a professor of social artificial intelligence and robotics at the University of Twente in the Netherlands, and I am also the director of the Dutch National Institute of Mathematics and Computer Science. And I want to tell you today a little bit about the research that we did quite a while ago around social robotics to help children with severe autism. So let me tell you a little bit about myself first, so that you know where I am coming from. I have a background in computer science, but then I started to look a lot more at how people with different backgrounds, different cultures, perhaps different vulnerabilities, different languages, how they use at that time the internet and computers, and how we could design these computers in a way that makes sense to them, to help them out in their daily life. And over time, I moved more towards robotics, artificial intelligence, technology, and how we can help that to support people that are, of course, very diverse in their background, in their preferences, and in their needs. So here you can see a little bit of my previous jobs. Before I went back to the Netherlands to go to the Center of Mathematics and Computer Science, I was at Nanyang Technological University in Singapore, the head of an institute called NIST, Institute of Science and Technology for Humanity, where we focused on connecting across the STEM and the shape sciences to deal with the large societal problems of our time, among which, of course, access to healthcare, aging populations. Okay, so I have been researching robots and the deployment of robots in populated situations since about the turn of the century, I want to say. So very, very early robots, just in the early 2000s, we were still exploring what could that look like. You know, one day there will be robotic services. What will that look like? And of course, the challenges were mostly technical then. It was still a real challenge to integrate computer vision with navigation of a robot, with calling up certain maybe little services that we could offer, because everything was kind of functioning okay in a lab setting. And computer vision for a robot to maybe recognize a person and know that it's a person and not an object. At the time, it was kind of working in a lab setting under certain conditions, but to do that outside with changing light conditions, where the context is very different from time to time, was a real challenge. So those first years, we really had to focus on the technical challenges of integrating all the different capabilities in computer science, in design, in interaction technology, machine learning, navigation, manipulation, to be able to come to robots that could function in a non-regulated setting, in a hospital or in an outdoor public space or in a shopping mall or in a school. So those were a lot of the projects that we did, and slowly we would get a little bit better. The technology, of course, would get a lot better, and we would become less and less stuck with these huge robots with stacks of laptops and technology. We have a little bit more freedom now to deploy robots in real life situations. So we have been doing a lot of research around many different challenges. Of course, elderly support, in work settings support, cobots, but also with children in educational settings, in hospitals. So I wanted to start a little bit with kind of how we developed our thinking around social robots in settings for children. Here you can see one of our very first robots. I'm just going to turn this on. I'm not sure if the sound will work for you. The little boy was speaking in Dutch, so if you couldn't quite hear what he was saying, that's not weird. But here a child was working with a robot around a little project around mass and weight, how that works in physics. And together with the robot, they would put little boxes of different masses and different weights on top of on top of a balancing rod, and then to see how does that work? How does it work to balance weights and balance masses? And the boy would do that together with the robot, well, together by interacting with a robot. And here the little boy, you could see, was asking the robot, "Hey robot, what do you think of it? What is your opinion about it?" And this is, I think, around, I don't know, 2005, 2006, well, quite a long time ago in this line of research. And of course, what we were noticing is how children engage with a robot compared to other learning technologies, that they engage with a robot almost directly in a social way, the way that they would do with a co-learner, with another child. And at the time, the thinking, because I'm a computer scientist, but of course collaborating a lot with people in education and child development, our thinking was that for children, when they receive education, it's really great for them when they can learn together. And if they can learn together, explain things to each other, that really benefits learning. But the materials and the lessons and the way that the learning happens often doesn't take into account the individual needs of each of the children that are learning together. One child might be really quick to pick something up and become bored. Another child might take some more time and then therefore not learn what was hoped to be the learning goal. But of course, if you would use technology, you could take into account the different paces and the different ways in which children learn and be able to personalize, even within a collaborative setting, the type of information that a child would be able to get. So here of course, this is one child with one robot, but our interest was to look at how do kids learn together? How do they play together? How do they engage together? And how could we develop technology that could support that? So I will show you a project where we looked at little groups of children, where the groups of children would engage with each other in some kind of a learning task in a game-like setting. And we wanted to be able to know when they were constructively learning and socially engaging with each other, really showing pro-social behavior, having a good time together, helping each other. And if a robot could maybe, or computer could maybe detect whether pro-social or maybe not very constructive learning behavior was happening, to adapt the learning material, in this case, a game around tidying up and sorting, to be able to adapt that so that pro-social behavior would be motivated and the children would optimally kind of work together, engaging in the task. So we'll show you that video now. So this is the squirrel robot that we developed for this purpose with our partners in Europe. And it is a combination of many different technologies of behavior analysis. And of course, we had to analyze children's behavior. So we had a lot of kids kind of collaborating together on games, and we would analyze the sound of their speech, their body movement, tracking, say, of their skeletal data, and then annotating that. So through machine learning, that the computer could recognize, okay, when are kids, do we feel working together in a really constructive social way, and when maybe are there kind of less social behaviors going on where that collaboration and learning is not optimized. And could we develop maybe a game around sorting and dealing with clutter? Could we develop a game where a robot would constantly kind of analyze the children's collaborative behaviors and then adapt the game to make sure that, for instance, if one child is left out, that child is pulled back into the game, and really optimizing the collaboration between them. So here are a few examples of the kind of interventions that were developed in the course of this work. It's really co-design with the children, finding out what kind of behaviors they find normal in certain situations, how they would interpret a robot's behavior, what they feel could be. Yeah, of course, it's very challenging because how do you engage children in co-design is a very challenging way, and there are no methods available. So this is, of course, really, really interesting to explore together. Now, if you want to support children with autism, and especially children with far on the spectrum of autism, of course they have, I'll just let this run a bit still. It's kind of fun. It just shows a little bit more how the kids played with the robot. But say that you want to develop embodied technology to support children with severe autism. And when children are severely autistic, they sometimes don't have language. They don't have access to language. They don't understand language. They can't produce language, let alone the intricate kind of social cues that we are constantly sending each other when we are frowning, when we think things are not so great, or if you're confused about something. For kids that have severe autism, there's so much going on. It is really difficult for them to be able to have those signals come into their minds to be able to know what is going on. And it's basically, there's too many impulses around them. They will shut themselves off from the environment because there's nothing to read. It's just too complicated to be able to read what that person is saying to them, let alone trying to say to them in their body language and in their social language. So that is a real problem, of course, because if you have a child that is severely autistic, you are very worried about them. You want them to be able to engage in the world and to have some independence in the world. And when you are a child, you're kind of forgiven if you don't understand that someone is angry with you, or you didn't understand something. But as you get older, people are less forgiving, and it can also, be quite dangerous situation for you if someone tells you, hey, you should stop, and you don't understand what's going on and you don't stop. These are difficult situations. So it's really a shame that we are not more accepting of neurodiversity, that in our world we don't have better understanding of people with autism, and that we are totally integrated the way that they and their brains function into our social worlds. And unfortunately, we are not there yet. And what we try to do now is to kind of train almost these children to at least, because it doesn't come naturally, to kind of understand the social signals around them. And that's very difficult when children are really very autistic, because if you explain to them, look, if someone is looking angry, that means they are angry with you. But they may not see that because they see an eyebrow here and they hear some sound, and there's so much going on. They don't put together that is an angry face. So how do you help them, A, recognize people's emotional expressions and emotional behaviors, and B, use their own face? You can imagine, if you're not aware of these signals, you don't even know what the impact your own face has when it smiles on the world. So with very autistic and very young children, how do you deal with that? That was kind of the goal of this project. And we wanted to kind of use robotic and body technology because it's much more controllable. You can use the face of a robot in a very controlled way to just show a very simple smile and keep everything controlled. And also, the robot is more like a mediator between the therapist or the teacher and the child, so that the complicated interaction that exists between the teacher and the child is mediated by the simple interface that the robot provides towards the human face and the human social behaviors. Also, the other way around, a computer can in much more detail and micro movements see how a child, for instance, smiles themselves. If you ask a child with severe autism, can you show a smile? A therapist sees a child a couple of times a week, perhaps, and they may not see any progression or degression in using their facial expressions. But with a computer, you can analyze micro movements, and you can have a much more finer monitoring of the child's progress in this. So now I will show you a video that will two videos actually in this. I think what you can see here, of course, with my partners Liz Bellicano and Maya Pentich on this project, is the approach that we try to take. I have another video. It showed one of the children in Belgrade. We ran these tests in different countries in Europe, and here you can see an autistic child in Belgrade interacting with the robot, and you can kind of see how the therapist is using the robot as a tool to be able to engage with the child. So here she's saying like, okay, what kind of emotion is the robot showing? You can see how the child is blocking the view of the therapist. You know, it's like that's too much going on there, but he is focused on the robot. So, you know, it's able to control which signals he's willing to process. And you can also see him smiling and laughing at the robot as the robot, you know, says, okay, yeah, that was indeed the right emotion. And of course, this is a wonderful video, but I also have many videos where children experience sensory overload from experiencing from the robot, from having many difficulties to get to a place where they could be open to learning about this. But for a number of children, we really think this is an avenue that could help them in receiving education. Thank you very much. I hope this was interesting to you, and I look forward to your questions.
Thank you, Professor Evers, for sharing thoughts. We have received quite some questions from our audience. Let us take a look together. The first question: from your experience, how the kids generally interact with the robots, what could be the advantages from eyes of children, carers, and professionals from your projects?
Thank you for your question. So the question is how kids generally interact with the robots, and I think all I can say is there is definitely no general interaction with the robot. You know, every child is unique. All of our children are so different in their personality, in the way that they interact, in the way that they respond, whether they are surprised, whether they are a little bit more frightened. It is very different. I would say that it takes us a lot of time and figuring out before we expose children to our robots, because we don't want to frighten them. We don't want to put them in a situation that is awkward to them. So there is a very long design process before we get to that point. And ideally, we want to design together with the children and together with their parents, carers, and professionals to be able to get to a form that we know will have maximum impact and will not have adverse effects on children. However, that said, you don't know on the long term what happens. That is why studies are so important before deployment in a way, or to have strong collaboration with ethicists, social scientists, child educators, child specialists, to be able to know, okay, what might be adverse longer term effects that we might introduce here that were never meant to happen. And I think we see that with a lot of technologies today, like ChatGPT or DeepSeek. You know, children engage with this technology, and it is helpful to them doing their homework. It is helpful to them, you know, working out questions they may have or problems they would like to talk through that they find difficult to engage maybe their parents or their friends with. And those are wonderful things. But at the same time, how are they developing their relation towards each other and their relationships towards technology? You know, what kind of agency are we introducing in the world, and what are the long-term effects on our children, but of course on everybody really, because we're all new to this type of technology. And that I find really challenging, to feel a little bit certain that we will be avoiding longer term adversarial effects, and especially when it comes to children, because they are in such a vulnerable part of their life, and the skills that they learn now, they will bring with them for the rest of their life. So we want to offer them everything to have a long and happy and fruitful life. And we don't want to introduce something that perhaps changes the way they relate to each other in a way that makes it difficult for them to have friendships or to have relationships, be a good father, be a good mother, be a good child, be a good parent, be a good friend. And that is why it is, I think, so important to take a lot of care, make sure that you have a very interdisciplinary team where you engage ethicists, child experts, and really be very careful before you introduce this technology in a very strong way into their lives.
Thank you. Next question will be, do you think robots for kids with autism is very culturally specific? Is this the major challenge that if we want to localize the use of robot invented from overseas?
Okay, thank you very much for your question. When I did my PhD, I feel 150 years ago, I looked at cultural background differences. If people from different cultural backgrounds had different needs when it came to interaction with computers. And one thing that I learned is that it is so difficult to know if something is because of culture. You know, if there's like a different preference between people from the Netherlands and people in China, why is that? You know, is that because of culture? Is it because of something else, right? Because it is so difficult to know what the reason is why someone has a certain need or a certain preference. For the project that I showed you, the DE-ENIGMA project of the robot for children with autism, we had a look at kids in the UK, United Kingdom, and also in Serbia. So while those are both European and Western, well, I don't know, Western is the right word, but European societies, the culture around caring for kids and also autism, therapeutic and educational settings were very different. We found that in England, it was very much language-based, even though a lot of the kids and the therapists didn't really use language. They would use language all the time. Like, this is really good sitting, good speaking, good smiling, a lot of verbal reinforcement and the sound and the intonation of the voice. And we noticed, for instance, in Serbia, that it was much more touch-based, holding, hugging, showing with the hand. And I think this is also our stereotypical view, right? Our stereotypical view of the British is they are reserved, they don't touch each other the whole time. And it's kind of funny to see that back. But I would say that of course, a cultural setting in the broad sense of culture is very important. And my grandmother was from Indonesia, and when she became older and developed dementia later in her life, we were able to find a place for her with all people from Indonesia. So all these elderly people that had dementia were all from Indonesia, and they would speak their own language with each other. They had their own dress, the way they dress, the way they eat. And that was really helpful because when my grandmother developed that dementia, she regressed to more childlike states, and it was very comforting for her to be in a cultural environment that was familiar to her. And I feel the same with any supportive technology, that it should fit what feels normal, the social normative situation that the users are in. And that is very different from culture to culture. For instance, healthcare is not the same across all different countries and cultures. So healthcare interventions also need to take that into account. How the local culture, what is seen as socially normative in that situation, to be able to be helpful there, so that people feel, oh, I know why this robot is here. I know it will be helpful to me. I know what it is doing. I understand what it is trying to do, and I understand what it is communicating, and it feels right to me. That is very important. And of course, that is a lot of that is on very careful design of the technology.
Thank you. Some robots now in the market is using a screen, for example, graphic to show facial expression. How do you see these different forms?
Thank you for your question. It's about kind of facial expressions for robots. I have to say I am I'm not always a fan of very humanoid robots. I don't like humanoid robots for no reason. In the video that I showed you today of the very human-looking robot, the Hanson Xeno robot that that had the little hair and was interacting with the child. I think there it is essential because what we wanted to teach the children is the meaning of people's physical emotional expressions on the face, facial expressions. So there you want to have a more controlled human face to be able to slowly build up to children, what a smile looks like. And a smile can be a very messy thing, so it's hard to recognize. But you want to start with something very clean and tidy, so to be able to communicate that. There, it is essential that the robot had facial expressions, but it has a purpose. And I think very often we kind of slap eyes on a robot because, I don't know, people see a robot and I guess it needs to have eyes. But I feel like you should only add things when they are really needed for the goal that you want to achieve. Same with natural language. As soon as a robot starts talking, saying something in natural language, people will have expectations. They will think, oh, it can speak, then it can also understand me. And then when they start talking to the robot, they might get very disappointed because, if it's a robot that's just there to, I don't know, pick up the bed sheets in the hospital and deliver them to the basement for cleaning, then, why would it need to be able to have a very extensive conversation with you? Probably doesn't have that capability. And very quickly you will be very disappointed in its capability of speaking with you. However, if it's a robot that is like a personal diary to you, to be able to do self-management of mental health, there it might make more sense that you can have really spoken conversations with it. So my advice would be to really think of what you like to support for your end users and what social capabilities make sense. If that is eyes, if that is speaking, if it is having a head, facial expressions, etc. And I am always very conservative. I always think the least the better, to stay very close to the purpose that the robot is built for.
Thank you, Professor, for the answer. The other question is, what social sectors or carriers could do to facilitate the R&D of the robots in the future? Anyways, we can participate or collaborate. Your robots maybe can trial in Hong Kong.
Thank you for your questions or your reaching out for collaborations. I mean, this is a wonderful question. Of course, it would be wonderful to collaborate more. And I personally am very interested to learn about kind of the different contexts of healthcare in the Asian world and in, for instance, Europe. Very likely it'll be very different from location to location, of course, everywhere, also in Asia, of how people will respond to robots. So I would say that maybe in some cases, certain kind of hardware look and feel of a robot could be like transferred across, and kind of we could make it work, and in the setting, for instance, in a Hong Kong hospital setting compared to a hospital in say Germany or the Netherlands that we would have, and it might be, for instance, possible to do that, but I think it would be really good to take a step back and have a real deep understanding of what the differences are. There might be totally different problem space in the hospitals in Hong Kong compared to the hospitals in the Netherlands, and the needs of people also. So I feel that, for instance, I for a period in my life grew up in Nigeria and Africa, and it's very, very family oriented. In the Netherlands, when you're in the hospital, you're either you're with a couple of people in the room, but you're kind of on your own and your family can visit you. But it's very different from Africa, like everybody's there all the time. It's a very social event, very different culture, and the technology would need to be able to deal with that. So I would think that would be very interesting to be able to understand the problem across different kind of cultural national settings and to see if the technology could work there. And it would be wonderful to collaborate, to have joint research projects between Hong Kong and the Netherlands. Also, I collaborate with a professor called Patrick Rao at Tsinghua University in Beijing, also has been doing this research for a long time, would be a wonderful collaborate. So it would be great to have a I don't know, some kind of international research group that we can have a look at what of these findings carry across, which of these findings are really locale specific that we need to take into account.
Thank you, Professor, for the for your valuable sharing. The coming sharing session by local commentator will be conducted in Cantonese. Please switch language channel if appropriate. 以下係工作坊3運用機械人提升自閉症兒童學習與社交本地評論環節。承接剛才 Professor Evers 所提出嘅國際經驗，我哋非常之高興可以邀請到蘇詠芝教授為我哋分享。蘇教授係香港中文大學教育學院教育心理學系教授。蘇教授喺2007年獲得芝加哥大學心理學博士學位，同年佢出任新加坡國立大學助理教授，並且喺2012年加入香港中文大學。佢嘅研究領域包括兒童嘅語言同埋手勢發展，以及自閉症兒童以及其家庭嘅介入。佢已經發表咗60幾篇期刊論文，並且創辦咗一家喺香港專門提供機械人介入服務嘅慈善機構。佢嘅研究、教學同埋服務都獲得咗本地同埋國際嘅認可。有請蘇教授為頭先Professor Evers 嘅專業分享，以及為本地業界未來科技應用作出回應。有請 Professor 蘇。
大家好，我係香港中文大學教育學院教育心理學嘅蘇詠芝教授，大家可以叫我 Catherine 啦。咁就好多謝頭先 Professor Vanessa Evers 咁精彩嘅一個嘅演講，等我哋都知道咧機械人點樣喺當地嚟到係去幫助一啲嘅自閉症兒童學習社交嘅。咁今次我哋都想一個少少嘅 recap 啦。其實點解會用一啲機械人嚟到幫助自閉症嘅學童咧？其實就係我哋都會知道自閉症嘅學生咧都好中意常規同埋可以預測性嘅學習環境。如果個學習環境好多時好多嘅變化，例如人類嘅面部表情啦、眼神接觸啦，或者聲音咧，其實都可能會障礙咗佢哋嘅學習嘅進度。而亦都因為咁啦，唔知有冇大家發覺，當佢哋同人去互動嘅時候咧，都其實比較容易感到焦慮，或者甚至乎缺乏動力。亦都係有一啲嘅自閉症學童都會反映翻俾佢哋信任嘅大人聽，其實就係佢哋都會擔心對方唔知道點樣係去睇佢啦，又或者一啲嘅批判性嘅眼光啦，都會令到佢哋唔舒服嘅。途中咧就係我哋自己基哥伴小星 Rabi 嘅機械人，無論係邊一種類嘅機械人，或者係 Professor Vanessa Evers 嘅機械人咧，其實都係可以都幫助到自閉症嘅學童嚟到係去學習社交嘅。係啦，咁我就有少少 recap 嘅。Professor Vanessa 咧就喺個演講入邊啦，都提及到有好多唔同種類嘅機械人，佢哋個團隊都有用嘅。咁右邊嘅圖咧係一啲嘅 snapshots 俾你哋係去睇翻嘅。其實佢用咗好多唔同大小類型嘅機械人，呢啲機械人咧，佢哋都發覺佢哋呢一班嘅自閉症學童好願意同佢哋進行互動。而當佢哋好願意進行互動嘅時候，亦都包括咗當機械人落一啲嘅指令啦，希望佢哋或者邀請佢哋係做啲分享啦，或者幫其他人嘅行為咧，佢哋都好樂意嚟到係去做嘅。咁因此啦，呢個機械人其實好容易地係去做到自閉症兒童嘅學習夥伴。我講嘅學習夥伴嘅意思就係話，機械人可以引導甚至乎領導呢班自閉症兒童究竟喺嗰個環境裏邊應該要做啲乜嘢，應該做一啲乜嘢嘅好嘅行為啦，例如就係話點樣同人分享啦，點樣幫人執拾啦。咁其實呢一個都係機械人可以做到嘅 一個好好嘅一個夥伴上邊嘅行為，同埋啦，因為咁咧，亦都可以建立咗一個協作同埋親社會，我哋英文叫 pro-social 嘅一個學習環境。一個協作環境其實都好需要一個 leader 領導者嚟到係去領導翻自閉症學童究竟應該當時嗰刻要點樣係去做嘅，而機械人亦都可以透過好多追蹤佢哋嘅眼神啦，追蹤佢哋嘅行為，而作出一個深度嘅分析，而去知道每一個嘅學童佢哋嘅強項啦，或者有啲乜嘢係需要再改善嘅地方。而喺一個協作環境裏邊，因應住因為佢哋已經有咁樣嘅 data 嚟到係去做一個 reference， 做一個參考啦，所以佢會知道邊一啲嘅小朋友係可以比較容易去做某一啲嘅行為。咁所以喺個協作環境上邊咧，就大家小朋友就合作得非常之暢順啦，因為佢哋都係用緊佢哋自己係可以做到嘅嘢能力咧嚟到係去展示俾大家睇嘅。係啦，咁呢班自閉症學童亦都可以透過機械人去學習同埋理解表達情感啦。咁呢個係佢哋用咗 Milo 嘅機械人，呢個 Milo 機械人咧可以模擬人類嘅面部表情嚟到做出相應嘅情緒，表達相應嘅感受。咁呢一班嘅小朋友其實望到 Milo 係去展示嘅機械人嘅時候，係俾人類去展示同一個情緒咧，佢哋嘅壓力係少咗嘅，因為佢都好清楚機械人嘅情緒個威逼感或者焦慮感係冇咁大。從而啦，如果喺日常生活環境或者喺臨床啦同埋教育上邊咧，其實係機械人可以用咗一個 mediator， 即係頭先 Professor Vanessa 都有講過 mediator 個角色就係話，當喺呢個機械人就喺老師同埋學生嘅中間，又或者喺個臨床治療師同埋嗰個 client 嘅中間扮演一個好重要角色。有陣時呢個小朋友未必好清楚對方嘅要求嘅，咁佢就會有啲焦慮啦，因為對方始終係一個人類，有情緒啦，亦都會有佢哋嘅期望。咁但係當機械人喺融合中間嘅時候，佢哋就會覺得舒服咗，同埋個指令亦都可以由機械人嗰度再發一次嘅，咁就比較有系統性一啲啦。係啦，咁其實咧，機械人喺自閉症上面嘅應用咧，已經開始係好廣泛㗎啦。我哋個團隊早喺10年前嘅時候就已經係開始做，咁而家我哋都係服務咗好多自閉症學童。咁 Professor Vanessa 都講到，佢哋喺歐洲嗰邊都係大量地係去應用。好多時候做緊呢方面嘅服務嘅時候，係需要一個跨領域嘅一個嘅團隊嘅合作。頭先 Professor Vanessa 都講咗嘅，要機械人做一個協作嘅一個調解人咧，即係協作環境裏邊嘅調解人，係好需要知道每一個學童嘅特色。要點樣知道特色咧？就係好需要追蹤同分析學習者嘅行為。咁呢個係需要一個龐大嘅數據同埋一個龐大嘅偵測系統。咁呢個就係好需要有待工程師啦，或者科技人員嚟到係去開發。嗱，開發咗之後咧，並唔係完結嘅喎，因為咧始終都要治療師同教師係去接受呢個機械人。咁當然啦，佢有好多好處嘅，但係用好處之前咧，都需要佢哋唔同嘅 stakeholders 咧，係到係去接受點樣係用呢個即係使用呢個機械，要接受好多嘅培訓，而佢哋嘅時間上邊嘅 commitment 咧，都係需要嘅。而 service 即係嗰個服務嘅供應者都係可以恆常地係去俾咗好多唔同嘅一啲嘅課程俾佢哋啦，令到佢用機械人嘅時候唔會感到好大壓力啦，又或者更加唔會覺得我用機械人就好似用多咗樣嘢，要我做多咗樣嘢咁樣，或者係令到佢哋工作量增加。咁所以一啲嘅培訓咧係好需要嘅。到最後啦，其實我有最近一個諗法，就係話都好需要社區參與嘅。而喺外國上邊咧，有好多研究咧，最近呢5年裏邊啦，都幾多研究，就係邀請家長、自閉症學童嘅家長，同埋係負責教呢班學童嘅老師，嚟到係參與一啲嘅研究，因為佢哋嘅投入度喺入邊嘅時候咧，即係喺包括咗喺入邊嘅時候，佢哋可以話到俾我哋知，班自閉症學童喺度諗緊啲乜嘢，甚至乎如果再做得好一啲嘅話，就真係邀請自閉症人士嚟到擺咗喺研究同埋一啲嘅服務供應嘅層面上邊，係俾我哋一啲嘅建議，甚至乎係一啲諮詢。因為好多時候我哋未必真係好清楚自閉症學童佢哋需要啲乜嘢，因為我哋從一個觀察者啦，又或者從第三者嘅角度去諗，但係其實可能某一啲嘅訓練對佢哋嚟講好大壓力，又或者佢會覺得我哋其實長期呢啲訓練都缺乏咗某種嘅成分。咁所以啦，如果係俾到一班自閉症嘅人士過到嚟係一齊參與成個設計嘅話，課程設計咧係會更加好嘅。 講到課程設計嘅時候咧，我哋基哥半小星都有12個課程，係超過300堂。咁而家我哋呢300堂都係為咗幫助呢一班嘅自閉症學童啦，3到18歲啦，嚟到係去幫助佢哋增強佢哋嘅社交認知啦，同埋增強咗佢哋嗰個對話溝通，同埋喺同人相處嘅時候點樣提升個韌性啦，尤其是喺逆境或者佢哋覺得唔順利嘅境況入邊。嗱，講到呢啲課程嘅時候咧，都令我諗起，如果係講緊同跨界別喺度合作，唔知道一班有志於服務老年人嘅一啲嘅大眾啦，或者一啲公司啦，有冇興趣地係去開發一啲由自閉症學程發起嘅應用喺老人痴呆嘅患者上邊？因為其實自閉症同老人痴呆有啲嘅共通點嘅，佢哋社交上邊都會有挑戰。亦都當然啦，成因唔同嘅。自閉症就係因為懷孕嘅時候腦部發育有啲異常啦，而老人家就因為佢衰退，但係佢哋嘅表徵亦都係唔識得同人溝通，唔識得表達情緒。其實如果機械人係可以幫助自閉症學童去學習社交、同人溝通嘅時候，我都好相信機械人亦都可以幫助老人家，就老人痴呆嘅老人家嚟到改進佢哋社交。目前咧我都知道，機械人其實係幫助老人家喺屋企，譬如防跌啊，或者整一啲嘅alarm 嘅系統啊，其實可以做多少少嘅，可以喺設計個課程上邊、內容上邊可以更進一步，令到佢哋可以喺屋企或者喺老人嘅院舍裏邊，透過機械人嚟到係去學習一下點樣係去同人互動啦、社交啦。點樣係去表達佢哋自己情緒，或者係去控制佢哋情緒上邊嘅一啲嘅有陣時憤怒嘅情緒咁樣。係啦，咁我今日咧呢方面就係講咗咁多啦。咁我最希望就係大家喺呢個Challenge Corner 呢個挑戰角裏邊咧，我哋可以再深思一下，令到機械人嘅服務咧可以更加廣泛。多謝大家。